welcome to the another lesson. So our today's topic is frequent pattern growth, FP growth algorithm. So myself Priyanka Gupta, I am working as assistant professor in Department of Computer Science at Institute of Aeronautical Engineering, Hyderabad. I'll cover the topics today. We will go into the introduction of FP growth algorithm. What is FP means of? What is FP growth algorithm? Earlier, we have used the a priori algorithm for frequent item set generation. But what is the need to go into the FP growth algorithm? Then we will see the how to construct a FP tree. How to construct FP tree step by step. Then we will go into the advantages and disadvantages of the FP tree algorithm. Let's start. FP growth algorithm. So FP growth algorithm is an improvement of a priori algorithm. So in earlier lesson, we have seen about what is basically a priori algorithm. A priori algorithm used when we want to make some frequent items. So for that, when we will use the a priori algorithm, we are going to generate most frequent items, most possible frequent items. But now we are replacing it with the FP growth algorithm. So there were actually two drawbacks of the a priori algorithm. What are that? In that algorithm, at each step, candidate set have to be built. So each of the time, each of the circle, each of the iteration, we have to make a candidate key for the tree. And second was to build the candidate sets, the algorithm has to be repeatedly scan the database. So we have to scan again and again the larger database. So that was taking time for that. That was slower in the performance. So basically, to rid of that, we are going to use the FP growth algorithm, right? So these two property inevitably making the performance slower, as I have said. So to overcome these of the redundant steps, a new association rules mining algorithm, that is nothing but the frequent pattern growth algorithm, were developed. So the FP growth is nothing but the frequent pattern growth, calls as a frequent patterns growth algorithm. So the frequent FP tree, the frequent pattern tree structure is a data structure. So it is a tree data structure for storing the frequent pattern. So here we are going to store the frequent items. The FP tree is the data structure of the FP growth algorithm for mining the frequent items from a database by using the association rules. So we have basically not gone into the association rules, how to make association rules, but yes, we have seen the how to make the frequent item sets from the different data sets. But here what we are doing while using the FP tree is nothing but that is a data structure to find out the frequent item sets from the database by using the association rules. So these algorithms were basically designed by to operate on databases containing the sum of the transactions, that is the purchasing patterns of the different customer. Suppose if some of the customers are there for the Amazon website, so they are going to purchase. What are the things they are going to purchase? We have to see their history pattern we are going to check. So that was the example. So here the purchased item will be the frequent item, right? So the frequent item will be the purchased item, right? So the similar frequent will share the similar branch of the tree. If we are going to construct a FP tree, we have to add the sum of the nodes there. But while going to make the that FP tree, the similar frequent nodes will be there. So if that will be there in frequency, that will be added. Otherwise, it will be removed from that node, right? So we have, otherwise we have to, if they will be differing that, we have to split them. We have to split them from that node, right? So the nodes identifies a single item from the branch, that is called as a set of item. So while we are going to construct a FP tree, while we are going to construct FP tree, the branch will be the set of items. So the single item will be the branch, right? The branch, that will be the path that is showing the number of occurrences, how many times the item is occurring. So that will be the occurrence links between the items, called as a node link. So that node will be counted as called as a node link in the FP tree structure. So this structure helps to find out the required frequent item set repeatedly. So that is in nature of fast searching. So we are using that FP tree. So internally, the FP tree is this type of algorithm that does not require any candidate key generation. But prior we have used the a priori algorithm. There we have to set the candidate key, and again we have to check for the candidate key from the whole of the database. There no need of to go into the database. We from the item sets we have to generate their FP tree branches. So this algorithm is going to use an FP tree data structure that does not require the generation of candidate key. So explicitly making the algorithm works better with the large data set. So that I have said, that is fast in nature, that is not going into the database again and again. That is not is a type of iterative. But yes, we have to check for the each of the transaction, what are the different items are there. We have to add that items as a branch in the tree. It also retains the item set association information. It is also having the item set association information for each of the nodes. Let's start with a small transaction data, that to understand, to know about the construction of how we are going to construct a FP tree. So suppose we are having the transactions in which we are having the 5 different type of items. So first item is asparagus. We are calling it, we are denoting it as A. Corn, C. We are denoting in our tables with the letter C. Beans, tomatoes, and squash. So for the first transaction T1, that is consisting the 3 items. That is here. This is the table 1 that is having the all of the 9 transactions T1 to T9. That is having the transactions, and that is also having the list of items in the each transaction. So in the first transaction, that is having the 3 items named as BAT. B is nothing but the beans, A is asparagus, and T is tomato. So the first transaction, it is having the 3 items. So similarly, the transaction T6 contains the item asparagus and squash. So we are having that table. One table is there that is having the 9 items there. The 9 transactions are there, basically transactions IDs from T1 to T9, and that is having the list of item in each of the transaction, right? So in the first transaction T1, if you will see that is having the 3 items there, that is B, A, and T. So B is known as a beans, A asparagus, and T tomato. In the T6, if we will check for T6 transaction, there is a asparagus and as far as squash. So from like that, we have to understand about the each and every transaction, right? So we will go into the how to construct the FP tree. how to construct a FP tree with having these of the 9 transactions in the with the different item sets, right? So in the first step, we are going to check the counting the occurrences of individual items. So in this step, we are going to check each and every transactions that is having the from T to T9. So in T1 transaction, how many items are there and what is the count of them? So we will count for that for the each of transactions. So if suppose the T1 transaction is having the asparagus, so for the each transaction till 9, we have to check for how many times the asparagus is there, occurring there. So first of all, we need to create a table, the table of items count in the whole transaction of data. So here it is. So this is table 2 that is constructed from that main table. So from the main table, we will count the how many number of items are there. So here we will take the item name and support count. So support count is nothing but how many times what is the frequency of occurring the item is there in the transaction, whole transaction. So we will check beans that is there in the main table, that has been occurred for six times, asparagus 7 times, squash 6 times, corn 2 times, and tomato that has been occurred for 2 times. So now in the next step, this is to what we have doing in this step, we have to simplify that each of the step, each of the count of each of the item. Like if we want to check for the squares, so squares has been bought in the 6 transactions. So that has been bought in the T3 transaction, T5, T6, T7 and T9, so on. So the support count will be for that 1, 2, 3, 4, 5, 6. 6 times that squash has been occurred in the transaction, each of the transactions. So that was the main purpose, how many times the one item is going to occur. So we will find out the support count for that. We need to find out the support for that. In the next step, steps 2, we have to filter out the non-frequent items using the minimum support, because we have to remove those of the non-frequent item from the list. We have to discard those of the item set which is not which is less than into the what we have set, that is set. We have to set the minimum support for each of the transaction. So that will be the if we have set the minimum support threshold as we can say 3. So minimum to 3, no, we have to take the maximum to 3, but we have to discard the minimum to 3 item sets from that transactions. So here, if we will consider for this example, this main table, if we will take the minimum support count as a 2, here we are taking it as a 2. So we have to check each of the transactions with 2. If more than 2 support count is there, we will consider that in the next table. So now we have to create a new table for what how many times we will compare the minimum support threshold 2 with the each of the items which we have written in the table 2. So every item we can say item set with fewer occurrences than the minimum support. So that will be excluded, that will be removed from that table. So this means that we are going to discard items, but here no items has to be discarded. Why so? Because here, as we have set the minimum support as 2, here we have set the minimum support as 2. So from this table, this is table 3 actually, that has been recreated. But if there would be one item as said French bean that has support count 1, so that we should have to discard from that new table. So because that is not having any support count less than the 2 minimum support threshold, so we have to keep that same table as it is in the next. But yes, we have to now we have to reorder that all of the transactions. So that will be in the descending order. So the highest number count will be there in the front. Now next till next like that we have to reorder the whole of the table in this new table. Now we are going into the step 3. So in this step we have to order the item set based on the individual occurrences. So here we will check the individual items, how many times it has been occur. So we have to reorder that. So next we just need to sort them, the item list what I have said in earlier. So this is the actually this step. In step 3 we have to reorder that items as from the table. So the order for that will be based on the support count, that is nothing but 2. So hence the table of support count may now be represented in table 3 that has been showed in the earlier slide. So there the beans and squash has the same support count of 6, and any of them can be written first. So we can write squashes first in that table in order, or we can write the beans as a second item in the order that is having the same support count. Here we have written bean first. Similarly, the corn and tomato that can also be listed in the same way, that is also having the same count as 2. So in any order we can keep the items if they are having the same support count. So in table 3 we have just reordered the items count on the base of support count all the items in order. Now that is the step 4. So here we have to create the tree. We have to create the tree and we have to add the transactions one by one. So step by step we have to make the different transactions. So in the main table we were having the T1 to T9 transactions. So for the T9 transactions were there. So for each of the transactions we have to construct the tree one by one. How to make the tree we will see in this step. So now we can create the tree starting with the first transaction. So each product is a node in the tree. So as in this figure figure 1 we can see the here in the left side we are going to, for our understanding, we are counting the overall count for the each of the item. In the right side we are going to construct the original tree. So for that first table there were the asparagus, right, beans and tomato. So that was the order was that beans, asparagus and tomato. So here we have counted the asparagus as 1, corn item is not there, so kept as 0, beans is 1, tomato is 1 and squash is 0. So now we are going to construct the tree for the first transaction. So here we will take the null node. Null node will be there because we have to sometimes rearrange the tree and branches as per need. So here we will take the null branch. Next to sub branch we will take as a asparagus as 1. So asparagus is there, that is 1. Now beans is there 1. Tomato is there 1. So we will construct the tree like this, that is having the asparagus, beans and tomato in the list. Okay. So now in this second transaction we have constructed that tree that is having the null node. Asparagus has 2 count, support count. Beans is in left hand side, that is having the tomato subnode, and in right hand side the corn is there as support count is 1. So that was the tree after the 2 transactions. Now we will go into the third transaction. So in the third transaction we will at the how many support counts are there overall. So now the asparagus will be 3, that is because that is occurring again. Asparagus, corn was there earlier, beans were there, tomato was there, and the squash has been added now. So that was 0 earlier, now it has been added as 1. That was 2 earlier, that has been added. So the 2 items has been added into the third transaction. So now we will construct the FP tree for that. So the null node will be added to from the null node, the asparagus node will be added. So that was 2 earlier, now that we have to increase the count as 3. Now the left hand side beans and tomato subnodes will be as same like earlier. Here the corn were there as that has been corn as 1. Now we have to add the squares. So here we will add the squares as a 1 support count. So that is the tree after the 3 transactions. Now we will get into the 4th transaction. So here the slide is having the 5th transaction. So for 4 we will suppose we have to imagine how to create the the FP tree from the 4th transaction. Suppose in the earlier slides we have to count the overall counts for the each of the items. So here as we have seen, the asparagus were there as a 3 item. Now we have to increase that as a 4 items. Corn were there as a 1. We have to increase this as a 2. The beans were there, that was 1. That was 1. Now it is 2 for the 4th transaction. And tomato were there as a 1, as same as earlier. Squash were there 1. Now it is 2. So now we have to add these of the 4 items in the next FP tree. We have to construct FP tree for that. So now the null will be there as the base node. Then the asparagus will be written as the that was 3 earlier. Now it will be written as a 4. So now in the left hand side, the beans and tomato will be same as like earlier. But here what we have to do, we have to, the squash has been already added, the corn that was already added as a 1. Here what was there, the asparagus were there, that was 4. So the asparagus has been increased as a 4. Now what is there, the corn is there, but that is corn is directly added with the asparagus node, but that is occurring with the, that is the in the 4th transaction, the asparagus is there, bean is there, squash is there, and then corn is there, like that. So suppose because the corn is already there in the connected with the asparagus, but now we have to add that in the order to other items. So now we have to add the corn there. So we have to add it with the beans, because it has been occurred after the beans. So that is the main connecting node will be the beans, because it is occurring after the beans. So we have to add the corn sub node with the beans as a count as a 1, right? So we have added this, we have increased that this node as a 3 to 4. Now we have to add the beans and squash. So the beans that has been that is occurring after the asparagus, squash, and then beans. So now what we have to do, squash is already a sub node. So we cannot add directly, because there should be some order to add each of the items. But directly we cannot add here. Now what we are doing, now we have to make it as a sub node of the null node. So now we will add the beans as a one item, and then again we will add the squash with that sub node with that. So like that the FP tree will be constructed like that. For the 5th transaction we will see now. So this for the 5th transaction, so the asparagus is there as a 4th count, corn is 2, beans is 3, tomato is 1, and squash is 2. So now for this transaction, the items will be added as a asparagus 4, the corn will be added as a 1, squash will be added, the beans that subnode will be as same as earlier. The beans and squash will be added for the that was common for the fifth and fourth item. If something has been missed, you can assume as earlier as I have said for the third transactions. So that was that can be some confusing, but you can understand how to we are increasing the items here for the each of the overall count, and we have to add the different items subnodes with the according to the how it is occurring in the that transaction list. Now we will go into the sixth transaction. So for the sixth transaction, so we will see here in the sixth transactions, the asparagus is there, beans is there, and squash is there. So that has been increased with count because that was 4 earlier, beans was 2, and squash was 2. So here the 3 items has been added. Again, what we have to do, we have to make the FP tree for that. So as the bean is 3 here, so we have the asparagus will be increased as 5. The beans, that will be 2 because that is a connecting node of bean that has been connecting with the asparagus. So we will make the beans as a 2 here. Now the squash is there. So squash is in the right side of the asparagus. So we will make increase that as a 2. So the 3 of the items has been added here in the this FP tree for the 6 transactions. So the tree has been completed for 6 transactions here. Now we will go into the 7 transactions. So like that, the asparagus is has been increased as 5. The beans has been increased as 4, and squash has been increased as 4. So like that, again we have to add those of the items as per the order. Now we will see the 8th transaction. So now the asparagus is 6, beans is 5, and squash is 5. Again the same will be there. We have to only if the order is occurring for after the beans, we have to add the squash again here as a 1, and tomato that has been again 2 here. So we have skipped here. The tomato is 2. So here the that cannot be added with the earlier subnodes of the asparagus. So that is occurring after the beans. So beans will be the main connecting node for that. So after beans, the squash is occurring. So beans, then squash again for that has been counted as a 1 support, and then the sub node will be that for tomato. So like this, we have to complete this 8th transaction FP tree. Now the one last transaction is left, that is transaction 9. So in the 9th transaction, we will see the asparagus has been increased as 7, the beans has been increased as 6, and squash has been increased as 6. So now we have to check, we have to add, we have to increase the count for that. So asparagus is there because that is a connecting node, so that has been increased to 6 to 7. Now the beans has been increased as 4 because it was 3 earlier. So now the beans is the second connecting node. So from the second connecting node, the squash has been added already from the 8th node. So we will make it increase the count as a 1 to 2. So, and the other item will be same as earlier. The tomato was 1 earlier, so it will be 1 earlier. So here the squash will has been added to 2. So the tree for that 9 transaction has been completed now. So yes, so there were the beans also were there. So beans were there as a 5 count. So now the 4 count has been here, and the 1 count we will increase here also. So in the 8th slide we have missed that. I can. So we have to add the beans here and squash here. So like that, that is the final FP tree made of that 9 transaction out there that were having the 5 different items as asparagus, squash, tomato, beans, and corn. Right? So now we have to cross verify using the that we have got the table. We have got the table 3 earlier. That was having the descending order of the each of the item count, support count, and now we are having the figure 9 that has been made after the each of the 9 transactions that has been made as per as the how the items are occurring in the each of the transaction. So now we will cross verify that. So we have already seen this table, but I have again count. I have depicted here. So now the items are there, the 5 items, support count are there, 7, 6, 6, 2, 2. So now if we verify for beans, there are two nodes. There are two nodes, that B4 and B2. So that B4 was occurring in the left hand side, that was below to that was the subnode of the asparagus. And now the B2 that is again occurring, that is connected to the null node, that is having the B2 count. So the count matches with the beans count of the 6 from the table that was having the 6 count. So that was correct. That was verified. That is correct. So the count for asparagus, that was here at 7, and in the from the figure 9 we can see the asparagus is same as a 7 as been there in the table. So we have seen today how to construct the FP tree from the different transactions from the one database. So that was T1 to T9 transactions were there. From there we have taken the 5 different items, that was asparagus, tomato, corn, squash and beans. So from there we in the order of how the transaction how the items are occurring in for the one transaction, each transaction. So like that we have to rearrange we have to add the different items as a subnode from the on the that main FP tree. So like that we have to do that for the each and every transaction. So then after all, in the end, the original FP tree has been made from that. So now we will see what are the different advantages and disadvantages there. So the advantage is there for this algorithm, that needs to scan the database. That need to scan the database only twice. 2 of the times we can scan that, when compared to a priori, which scans the transactions for each of the transaction, each of the iteration. So that is the advantage, because that was taking the so much time. In this algorithm, that is taking the less time than that, and that is faster in that terms. The pairing of items is not done in this algorithm, and it is making it as a faster algorithm than the a priori algorithm and other algorithm. The database will be stored in the compact version in the memory, because it is having this data structure is having the structured nodes are there. So that has been that will be stored as a compact representation of that tree. So that will take the few less space to store in the memory there. It is efficient and scalable for the mining with the both long and short frequent items. So if there is a possibility, if long patterns are there, for that also this type of FP growth algorithm can be done, can be search for that frequent items, and for the smaller shorter frequent items can also be done from this algorithm. What are the different disadvantages are there from this FP growth algorithm? The FP tree is more cumbersome, and that is difficult to build than the a priori, because it is not if we are simply going to construct, that will not be constructed. We have to understand the each and every logic. So that is difficult to construct that tree than the a priori algorithm. It can be expensive some of the time, because for each of the iteration, for each of the transaction, we have to take some memory to store that, and again we are going to remove that. So again and again this is acquiring the more memory than the other algorithm. So when the database will be large, the algorithm cannot fit for that, because there will be the shortage of memory, there can be the loss of memory, there can be the more memory we want. So there will be that will not be possible to store. For that each of the data, each of the node in that type of, to construct that type of tree, so that will will get the more space required for that. So that was the some advantages and disadvantages from that FP growth algorithm. So that was all about the FP growth algorithm. That was all about today's lecture. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.